Hi people, and welcome to this complete tutorial for beginners in Autocad. First of all, I need to mention that this tutorial exists divided in 6 parts. The playlist that you can see here. Click on the card above if you prefer to watch it on that way. By the way, in the description of the video you can find the full list of contents, so it's going to be easy to access to the topic that you want to watch. This video is intended for learners that are using the software for the first time, and even I'm using the version Autocad 2020, I will conduct the lesson in a way that if you have a different version, it will not be a problem for you to understand. At the end of this tutorial, you will get the knowledge to draw most types of drawings in 2D, and solve your tasks easier if you are an architecture or engineering student, for example. Okay, this is the AutoCAD default display, which consists in different areas. Above, at the left, you find the application icon. This is the menu where I can open a new document, open a file, or do operations regarding saving or exporting a file. Then, the main part at the top is called the ribbon. There, you find the majority of tools you will need during the program. Right above, you can find these tabs which group the buttons in different categories. For example, the current one is the Home tab, which has the most used icons. If you switch to the Insert tab, I find in this case icons related to this category. Then, inside the specific tab, the icons are subgrouped in panels. For example, in the Home tab, the first panel have the icons which can perform drawing actions. In the second panel, they are related to modifying objects. And on the third panel are the annotation icons. Additionally, when you click in a panel that has an arrow facing down, it shows extra icons, which are used less often. When a panel has a diagonal arrow at the right, I can access to the settings window of this category. Now, let's show you how to use tools in AutoCAD. For example, imagine I want to draw a line. As you may guess, I can click in the icon here, I go to the workspace, I click for the first point, and then, where I want the second point, I click again. Simple. Then, I'm going to repeat the process, but this time I want you to pay attention to this, the command bar. This shows the operations that are taking place during the project. I will show you. I click again in the line icon and you can notice here line specify first point. The first word which appears in capitals is the command name, in this case line. Then, that's the prompt sentence, which tells me what I should do next. Though, I click here to specify the first point, then it asks to specify next point, click again. As you see, I just draw a line, but it keeps asking for specifying another point. It would draw a new line. As I don't want, I can press Escape to exit the line command. In conclusion, to perform any action in AutoCAD, I can type its command name. For example, I type line and press enter, and I can draw a line. Then press the button Escape to leave the command. Now, I want to draw a circle. I can click in its icon, or type the command name, which is circle. Additionally, each command has a shortcut called alias, so I don't need to type its full name. For example, L is the shortcut for the command line, and C is a shortcut for circle. During this tutorial, each time I introduce a new command, I make an annotation at the left part of the screen showing the command name, the alias and its location on the ribbon. This way of inserting commands makes AutoCAD easy to switch from different versions. If for any reason I'm going to a computer that has AutoCAD 2007, which had a different display than this one, I can still work with no problems, because the command names and their shortcuts are the same. Of course, some functions were not available in that time, but almost all the basics didn't change. The same applies to the version in Mac. Even AutoCAD 2020 there has a different display, the icons are in different places. You can just type the command names and don't need to worry to find them out on the screen. How to use the mouse in the workspace. Having a mouse is very important for working in AutoCAD, as it's much more comfortable than using just a touchpad, especially for zooming or moving the workspace area. Let's see the functions of the mouse buttons. Here I attach this image to help you. Mouse wheel. With the mouse wheel, I can zoom the workspace. It's very simple. If I scroll up, I zoom in. If I scroll down, I zoom out. The zooming always applies to the exact location of the pointer. For example, in this situation, if you want to zoom these objects, I need to move the pointer over them, scroll up, and you notice they are filling all the screen. Simple. To move the workspace area, press and hold the wheel. When you see this hand, you can move around. Left button. Clicking with the left button, I can select objects, like this circle. If I want to select the circle and the line, I can click first in one, then in the second, without pressing the Control key, unlike other programs. But now, imagine you have a bunch of objects to select. It could take a long time to select them all. For that reason, if I click in an empty space, a selection area opens. This allows me to select more than one object. However, this is important. There are two kinds of selection. If I open the area to the right, the color is blue. If I open to the left, the area appears in green color. What's the difference? When I open to the right, blue color, I have to cover the entire object to select it. If I would open to the left, green color, it's enough if I only cover one part. Also, you can understand if the object is going to be selected when you see it turning bold. Now the right button. The right button opens this panel with several options you can choose. But when you select an object and right-click, you can access, for example, to its properties. I click. It's a long list over here. I'm going to close it. However, there is a compact version of properties, Quick Properties, which contains the most important features. For this line, you can see the object type, line, color, layer, line type, and length. By the way, in the quick properties of this circle, some of the topics didn't pop up for the line, as they are more relevant for circles, like the diameter, radius, or area. In this chapter, I'm going to teach you to draw lines properly. The line is probably the most basic tool and the one you will use most of the time. Before, I showed how to draw a line but without any specified length or direction. I mean, if it's horizontal, vertical, or if it makes an angle with the x-axis, for example. That's exactly what you will learn the next few minutes. Draw a horizontal line. To draw a horizontal line, I need to activate first the command line. I can click on the icon there or type the command name, as you remember from the first chapter. Or I can simply type L, it's the alias for line, and press enter. I click anywhere on the workspace for the start point. Then I drag the cursor to the right and you can notice this dashed green line with these labels saying polar and 0 degrees. If I click right now, the line becomes completely horizontal. This happens because I have the polar tracking turned on, this icon located in the status bar. The polar tracking allows the cursor snapping to certain angles. By default, these angles are set for 0 degrees, 90 degrees, 180 degrees, and 270 degrees, making the lines vertical and horizontal. Now look what would happen if the polar tracking is off. Click on the icon, it's disabled now. Then I'm going to draw a line again, type L, press enter, click for placing the start point. Then, as I'm trying to draw a horizontal line, I realize that the dashed green line is not there. That means when I click, even the line looks horizontal, there will always be a slight deviation. So I strongly suggest you to use the polar tracking whenever you are making precise drawings. Draw a line with specific length. This time I'm going to draw again the horizontal line, but with a precise length of 100. It doesn't matter the units for now. As the last command used was line, I can press enter to revert to the previous one. Look, it turned on again the command. I click, I move horizontally to the right. Now that the line is on the direction I desire, I can type 100 and press enter. Easy, you just drew a horizontal line with a length of 100. But be aware, when I type the length, I cannot change the direction anymore. See, I move the mouse and nothing happens. So, if it's not on the direction you want, you can press escape. Now I can make it vertical, for example, insert the length again and press enter. To confirm this, I click on the line, right click, go to quick properties, and here you have it, length 100. Orthomode. If I want to draw only orthogonal lines, I can click on the icon Orthomode, restrict cursor orthogonally. Then, when I'm drawing a line, I can only make it horizontal or vertical. This can be useful if I'm at a part of a project where I just need those type of lines, like in the example here. Now, let's draw this line here with 70 of length, but with a 30 degrees angle from the x-axis, which you can check looking at the UCS coordinates. They are by default located at the left corner of the screen, here. So, I draw again a line, start point, I type 70, but this time, instead of pushing enter, I press the button tab, the one above the caps lock. With this way, I locked the length, but I can choose the direction. I place the pointer more or less here, type 30 and press enter. As you see, it's quite simple. Then, look at this different situation. The line makes the same angle, but in the opposite direction. I do the same as before, type the length, then look at this label showing the current angle while I'm moving the cursor around. It's increasing until I reach half circle, 180 degrees. Then it decreases, as now it's showing the other side angle. Basically, if I'm below the x-axis and type 30, the angle starts again in the same place but in a clockwise direction. Next to the line icon is the polyline. A polyline is a connect sequence of lines created as a single object. For example, let's draw this exercise here. I click in Polyline, choose a start point to draw the first line, go up and make sure you have the polar mode switched on. Type 20, press enter. Then to the right, I type 25, press enter again, and finally, vertically down. This is important, always click when the polar tracking is on the screen. Type 20 again, press enter and escape. So, if I click in the polyline, it selects the full sequence, as you see. Although I could use the command line to draw the same example, all the lines would be considered as separate objects. Now that you know the basics to draw lines, I want to introduce to you a very important function in Autocad, the object snap. This will allow us to make our drawings with the maximum precision. Take a look at the next example. Let's draw it. I can use either line or polyline command. I choose polyline. I'm going to type its shortcut PL. Draw the first line. Then the vertical one. As there is no line to continue here, I press escape. Now, the third line has to be connected to this intersection. I turn on the command line, I move the cursor near the left end of this line, and look at this green square appearing here saying endpoint. The same happens when I go to the other side. You can see it again. If I click right now, the next line starts automatically from that point. And it means the three lines are now connected to each other. Type 25 and press enter. Those green squares only appear because the object snap is active. It's this icon at the status bar. At the arrow just next, I can see the modes that are currently active. See here the endpoint, which is an extremity of a line segment. Now I'm going to introduce you also the midpoint. First, I'm going to click in it because it's not active. Then I want to draw a line from the middle point of this one. I activate the command line. As you can see, this triangle indicates the midpoint. I click now and the next line starts exactly from there. Object snap tracking. This is a very useful function, and I will explain it with an example because I think it's easier to understand. We have this example here, and we want to draw this line which is located at a distance of 30 from the right. I turn on the command line. Place the cursor on this endpoint. Drag left slowly so that I see this label that says extension. In this moment, if I type 30, the new line starts with that distance from the endpoint. It's simple, and with this we can avoid drawing extra lines. Then you just need to draw the remaining objects. To connect this line with the rectangle below, drag it down until I see this cross here. Now click and press Escape. Another way to use object snap tracking can be when I am drawing this rectangle. I can draw an extension line up from this point until I intersect the polar tracking of the line I'm making. Like this. So these kind of things are very interesting to play around. Now you need to make a bit of practice to strengthen the knowledge you got in this video. For that reason, I prepared these exercises for you. You can get them in PDF by clicking on the link available in the description. Part 2. I am going to explain to you briefly more drawing commands. Rectangle. A rectangle is in reality a polyline. It's just a faster way to draw this kind of objects, as I just need to specify 2 points. I'm going to show you. The command is this one. Specify the first point and then I only need the opposite corner. I can simply click to place it or insert the coordinates regarding the first point. That's what I'm going to do. The first blank is for the x-axis, type 40. Then I press Tab to switch to the second coordinate. This one is for the y-axis, type 20 and press Enter again. In fact, what I have done was inserting the length and the width. Simple. However, as I still have to take into consideration the UCS coordinates, sometimes the values might be negative. Let's suppose I draw another rectangle but with the start point. The x coordinates would be -40. Click for the start point, then type -40, press Tab, and as the y coordinates are positive, I type 20. Here you have the result. Circle. To insert a circle in Autocad, I can click in this icon, as I believe you guessed. Then, just follow the prompts to draw the example here. Specify center point of the circle. OK, I click anywhere. Then, specify radius of circle. It is 20. I type that value and press Enter. Let's do the next. Now check out this tip. As I want to use again the command circle, press Enter, the system automatically reactivates the previous action. This is very important to know, it saves time. I am going to draw the same circle again. Now, look to the prompt at the command bar, specify radius of circle or diameter. So, instead of typing a radius, I can switch to typing a diameter. I do it by clicking on it or simply type the first letter D. Then press Enter. As I'm drawing the same circle, the value is 2 times the radius. 40. Press Enter again. OK, this is just one of the several ways to insert a circle. If I click on the arrow below the icon, you can see all these options available. That depends the situation that you are drawing. Arc. An arc is a section of a circle and, like the previous command, there is an arrow below the icon with different ways of specifying points. I'm going to draw the arc of this example above, and the best option here is inserting the start point, then the center and finally the endpoint. By default, AutoCAD draws the arc in the clockwise direction. Let's click on the arrow, then find Start, Center, End. Click on the endpoint of this line for the start point. The center is the intersection between both lines. And finally, the endpoint is this one. See how the arc is being drawn clockwise. Modifying objects. Until this moment, I taught you the most used commands to draw in AutoCAD. In this section, I will introduce to you commands that will help you in modifying objects and to be more effective while drawing. I'm going to start with the basic ones. Move. To move an object to a different place, for example, want to move the small rectangle to a distance of 60 to the right, click on the icon, select the rectangle, press Enter. Specify a point from where I want to move the object. Then I move to the right horizontally and type the distance of 60. Press Enter. In the following example, I want to move the rectangle to the other box, which is located at the same distance from the corner as here. I activate Move again, I select the object, press Enter. But this time the base point is going to be the corner. Then I click in the next corner to move it there. Copy. This command works in the same way as the command Move. I'm going to copy the object to the first rectangle. I use this base point. Then I can copy it in this intersection. Then I realize I can keep copying the object the number of times I want. Do you see? It's very nice this. And when I'm done, I press Escape. Rotate. To rotate objects, I can use this command. Let's see how it works. I click on the icon, select the objects, press Enter. Then I choose a base point where the objects can rotate around it. As the polar tracking is on, I'm going to rotate them 90 degrees to this side. Another situation. The same objects are in this position. If I try to rotate them back to the position they were before, the polar tracking doesn't work this time. However, I can use a different way. If you look to the prompt, there is an option that says Reference. To use it, I can either click on it with the mouse or type R. Usually the first letter is enough. After, I can specify a reference angle or draw a reference line. Let's draw a reference line, I prefer this. Click here for the first point, then for the second point, I choose this endpoint. Finally, I can rotate until the polar tracking appears. Now, look at this polyline. With the command Offset, I can inscribe that polyline inside, with a specific distance. That distance is called Offset Distance, and it has a length of 10 in this example. Let's do it. The icon Offset is this one. Click on it, then, for Specify Offset Distance, I type 10. Select the polyline, I move the pointer inside and click there to draw the new polyline. By the way, if I click outside the area, the new polyline offsets outside the original one. The command Offset can also be applied to lines. If I have this line and apply offset to it, a new line shows up parallel to the first one. Now, I want to show you a situation that happens to a lot of people. I'm going to draw a rectangle with the command line. Then, I want to offset the lines like before. I type O to activate the command, specify the distance of 10, and when I click to offset, I realize I can only click on one line at a time, and the result is different than when I apply to polylines. However, I can easily merge lines in a polyline. There is a command for it, join. I type join, or I can still find the icon on the modify panel, here. It's very simple. Select the lines to merge and press enter. As you see, now I have a polyline. Finally, if I do offset again, the result will be identical as my first example. Command trim. In Autocad, we often need to cut parts of objects we have drawn before. For that, we can use the command trim. Let's check out how it works. I'm going to start with a very simple example. We have these lines, and I want to erase this segment. I click on the command trim, it's located there. Select both lines, press enter. Then, if I drag the pointer over here, the screen shows that this part will be erased. The same happens when I move the pointer to the other segments. I click on this one and you see it disappearing. It's done. To leave the command, press enter or escape. Look to the next example. This time we have 3 lines. I turn on trim again, select all the objects, and then I can erase any segment between any intersection, as you see. Now, suppose I want to erase all this part of the horizontal line. Turn on trim. The vertical line on the right I don't need to select, just the other 2. Press enter, and when I'm going to click on this line, it erases everything from the intersection of the lines I have selected to the right. Maybe for this situation this didn't make a big difference, but look at this case. Here I want to delete all this part of the line. If I select everything, then I need to erase one by one. It takes a long time, so it's better to only select the lines I'm going to use, like this. Of course, I can use trim not only for lines. It works for other kinds of objects. For example, I want to change this drawing to that one. I activate trim, select everything, press enter, and finally click on the parts to erase. Extend. This command is used to extend lines. In the example here, I want to extend this line to intersect the vertical line on the left. I am going to click on the arrow located next to the command trim. Then I select Extend. First, I have to select not the line that I want to extend, but the one where the extended lines will connect. So it's this one. Press Enter. Then I select the line to extend. To extend the line to the left, I have to click on the left half in order to work. Look if I drag the pointer over the right half, nothing happens. I go slowly to the left, and after passing the middle, the extension appears again. I click and press Enter. In this example, I want to extend all the vertical lines on both sides. I type EX, press Enter. Select both horizontal lines. Press Enter again. To extend the lines up, I can open a selection area to cover the upper part of all vertical lines. I click, then I do the same for the part below, to extend the lines down. When I finish, I press Enter to exit the command. Of course, in this situation there is a faster proceedment, by opening an area that covers both line sides. That extends both parts in just one step. Mirror. With this command, we can copy objects symmetrically. This is how it looks. Also, when we need to make a symmetrical drawing, we can just draw half of it and then use mirror in order to complete the process without spending time in drawing. Let's see how the command mirror works for these objects. Click on the icon, select everything and press Enter. Then the prompt asks me to draw a mirror line. I'm going to insert the first point at a distance of 20 from the objects. I hover the mouse over this endpoint, move right, type 20 and press Enter. I'm going to draw the line vertically and you can see everything reflected as a mirror. I click for the second point. Now, the prompt sentence says, erase source objects. I choose no to keep the original ones. Notice that all lengths are kept, including the distance between the objects and the mirror line. Now check out these considerations about command mirror. It doesn't matter the length of the mirror line, just the direction. As you can see, if I draw a long vertical line, the result is the same, only if I rotate it, the objects are placed differently. To make a symmetrical drawing, I just need to draw half of it, because if I draw a vertical mirror line in this endpoint, the new mirrored objects connect to the original ones. It's simple. Sometimes I don't want the original objects. In the option Erase Source Objects, I choose Yes. That's the result. Editing objects using grips. The blue icons that show up when I select an object are called grips, and they allow me to edit it. When I select the line, there are 3 grips. If I click in one at the extremity, I can change the position of that point, keeping the other end in the same place. If I click on the grip in the middle, I can move the line without changing the length and direction. Now let's see some editing tips. Change the line length by moving one of the ends. I'm going to click on this icon. I drag left, I'm going to type 10 and the line length increases to 80. Of course, this also works if I want to make the line shorter. Click again. This time I drag right, type 10 and the line returns to its previous size. To type a new length to the line, I click on the grip, drag left and this time I press the button Tab and the input switches to the full length. I am going to insert 120. Then, let's check out how grips work on polylines. The end grips of each line works in identical way. I click on this one to change its position, and you can see all the other vertices don't move. Of course, this may cause me to deform the polyline. Now, unlike the lines, the grip on the middle has a rectangular shape. I'm going to click on one, and I can move that full line. Then the rest of the polyline has to adapt to its new position. For example, I move right, type 10, and you can notice this line increases 10 of its total length. So we reached the end of the second part of this tutorial. Now I prepared more exercises for you in order to practice what you have learned here. The link is in the description of the video. After, don't miss the third part of this course, as I will keep teaching very important features for beginners, as set up units, work with layers, plot a drawing, and more. Part 3. Until here, I taught you commands to draw objects and modify them, but I haven't mentioned any units for the dimensions. When I was drawing lines, I said, draw a line with dimension of 50 or 100. I didn't say if it was meters, millimeters, inches or feet, but I'm going to talk about this now. First of all, Autocad uses adimensional units. This means that it's up to me to decide what is the unit of a line that has length of 20, 50 or 100. It's very simple. Let's suppose I want to make a project in millimeters. That's the unit I usually work with. I want to insert a line with 5 millimeters of length. I draw the line as usual, and when I want to set up the length, I type 5. Then, I'm going to insert a line that measures 1 meter. I do the same, but this time, for the length I type 1000, because, as you may know, 1 meter is 1000 millimeters. Now, let's go to the Unit Properties window. I type units and press Enter. Here, on the length section at the left, you can choose the format for units of measure. If you work in millimeters or meters, you should use decimal units. Instead, in some countries it's more common to use inches and feet. In this case, engineering or architectural units are more suitable. Below, you can set the precision. In this drawing, I consider the units millimeters, and I don't need decimals, so I choose the first option. At the angle side, I can choose the units for angles. Most of the time I use decimal degrees, but there are others here that could eventually be more suitable for you. The units in insertion scale are used only when I insert objects or drawings from a different file. Usually, when we start learning AutoCAD, I don't need to insert anything external. But, in my opinion, it's better to specify the unit. I click on millimeters. When I finish, I click on OK to exit. Layers. Layers is how AutoCAD organizes objects. For example, have a look to this file. Here I have 2 floor plans. It's a proposal for converting offices in flats. So, instead of having the objects all together, I decided to organize them in different layers. I am going to click on this icon to open the Layer Properties Manager. Here, you can see that I created layers to group different categories of objects. For example, I placed the windows in one layer, the walls in another, and I did the same for the doors, text labels, and so on. There are also other advantages in using layers. I can set up specific colors to distinguish them. Another thing. For easy access, I can drag this window to the left, and then I click on this icon to hide it automatically. Then I just need to drag over the tab to see the layers. Now I am going to explain to you how we can work with layers and tell you some considerations. New layer. If I want to create a new layer, I click on a blank space on this window with the right button. Then I click on New Layer. Then I can set up a name for the new layer, for example stairs. And if I click on the color, for example, I can change it to the one that I want. I'm going to choose this yellow. Under line type, I have a continuous line by default. However, if I click on load, I can find several line types, dashed lines or other formats. Clicking on this light, I can turn off a layer. For example, I'm going to turn off the layer doors, and you can see those objects disappearing from the screen. There is also the mode freeze. Even it looks like it has the same effect as turning it off, freezing a layer releases it from memory. You can notice the difference in the performance when you work with very large drawings, especially freezing layers that contain loads of 3D objects. Now, suppose that I want to move these objects to the layer stairs. I have to select them, go to the Layer tab, and change to stairs. You can see that they changed the color. Then, I want to draw a new line in a specific layer. First, choose the layer and then I can draw the line. It's simple. Always specify the layer before drawing to avoid changing it after. Isolate layers. To isolate a layer, I can click on this icon. Then I click on one object of the layer that I want to isolate. This operation locks all the objects inside the other layers, meaning that I cannot edit them. Now, this is useful for me to modify objects from this layer text. For example, I want to move all the text to the left. I activate the command move, open a selection window to select the objects, click for a base point, move left and click again. To restore all layers that were locked before, I click on the icon right below and isolate. Layer 0. If I move the pointer over the layer properties, you can check here the layer 0. This is the default layer anytime I start a new file. In any project, I recommend to you to keep this layer without objects there. You cannot rename it or delete it. However, this layer can be useful for creating blocks, which is what I'm going to explain on the next section of this video. Sometimes we draw something that it's easier if it would be a single unit. For example, a door. If we want to copy it, I have to select all the objects that compound the door. If we convert all these objects to a block, they act like a single object. So, I want to convert this door to a block. As it's on the floor plan, to be easier to select it, I'm going to isolate the layer where the objects are located in. Click on the icon Isolate and click on any object of the door. Press Enter and the layer doors became isolated. Let's use the command copy. Now, it's very easy to select only the door with the selection area. That's because all the other layers are locked. Press Enter and I can copy the door outside the plan. Creating a block. Before creating a block, I'm going to move these objects to the layer 0. By doing that, I can later move the block to the layer I desire and it gets its properties. I select the object and I'm going to click on the icon Create a Block. The block definition window appears. Here I can set up a base point for the door. I choose this corner here. Back to the window. I have to write a name for the block. I name it as Door. When I finish, I click on OK. So, the block is created. If I click on any part of the door, you can see that this is now a single object. Now I'm going to change the block to the layer that I want. And you can see, while I'm scrolling here, it changes the color to match the new layer. However, if I created the block with objects in another layer, for example stairs, I'm going to create the block. Then I'm going to change the layer of the block to another one, but it keeps the properties of the layer stairs. The layer 0, on the other hand, means that the objects don't have any layer assigned. Check out this example. Add doors to the floor plan. As you know, I have my new block here. With the command copy, I can insert them easily in the floor plan. I just have to click on the endpoints of these lines. A great advantage of using blocks is the ease of modifying them. I go to this button that says Edit Block. Then I choose the block Door. I click on OK. This is the block editor workspace, and also a new tab for editing blocks appeared on the ribbon. Here I can make all the changes that I want to this block. For example, I'm going to draw a circle here. Then I close the block editor and save the changes. As you can see, all the block references of the block door have a circle inside, which can save amounts of time. In this section, I am going to explain how you can print in Autocad. I know that a lot of people struggle with this topic, as it's a bit complex, but I will explain the most important tips to make it as simple as possible. First of all, look at the tabs located here. The first one that says Model is where we can make all the project. This workspace seems to have an infinite area, so we can make the drawings that we want. But of course, the larger the file, the slower the computer gets. The tabs that say Layout are used for printing. I'm going to Layout 1. Here, there is a paper with a specific size, and these drawings is what it would be printed. To print properly, we should specify the paper size that we need. I am going to click here with the right button, and then click on Page Setup Manager. In this window I choose Layout 1 and click on Modify. So here you have the page setup. First, we should choose the printer by clicking on this tab. If we want to save a page in PDF, there are several options here regarding the file size and print quality. I usually use this one, DWG to PDF. To change the paper size, I have to click on this tab. For this case, I want A4, this one. On drawing orientation, I choose between landscape and portrait. Finally, click OK and close to save changes. Now that we have the paper size, we have to decide what we want to print on there. On the Layout tabs, there are two spaces, Paper and Model space. We can switch between them here. Currently, we are in the paper space. If I apply zoom or move, it works for the paper. Notice this rectangle here where I have the drawings. It's a viewport, and it's like an access to the project. I am going to double click inside and it switches to the model space. Now, if I zoom, the paper doesn't move, just the objects that I drew. As well, if I draw a line here, it will appear exactly in the same place in the Model tab. Change the size of the viewport. I'm going to click on Model to switch to the paper space again. At this moment, I can select the viewport. Then, with the grips, I can modify it to cover the entire paper. Double-click to go to the model space. Now, I can zoom in the drawing or put a specific scale for the paper. It's here. I specify, for example, 1/100. When I finish, I am able to print the drawing. Click here with the right button, and this time I click on Plot. Continue to plot a single sheet. Here I can click on OK to print, or in this case to export a file as a PDF. Some printing tips. Hide the viewport. When I plot a file, the viewport appears by default on the paper. If you want to hide it, follow the next steps. Go to the Layer Properties Manager and create a new layer just for the viewport. Switch to the paper mode. Click on the viewport and move it to its own layer. Then, go again to the Layer Properties and freeze the layer. You can see that it's not appearing anymore. So, if you save as a PDF or print a file right now, the viewport is not visible. Have different colors on the viewport. The default Autocad workspace uses a dark background, with a reason to be better for the eyes when working for several hours. Because of that, it's common to use light colors in our project. The problem is when we switch to the layout mode, the colors can be too light for a white paper. For example, the doors are a bit hard to see. Don't worry, it's possible to set up different colors for printing. First, you have to double-click on the viewport to switch to the model space. Go to the Layer Properties and you can see this column with the label VP Color. If in your version is not located next to the Color tab, look at the right end of this table. Then I'm going to change the color for the layer doors. Click here and put this one, for example. Now it's much better. Insert text. I am going to explain to you quickly to insert text in Autocad. It's not hard and there are two types of text, single line and multiline text. I will start with single line text. First, we insert the start point. Then, this line specifies our text height. I can either click or specify a distance. I'm going to type 100. Press enter and then I choose the direction. If I want to type horizontal text, I need a horizontal line. Now I can write anything, and when I finish, I click in a different place to write another text. Or if I don't want more, I can just press enter or escape. Now let's see the multiline text. Activate the command. Choose first point, and I specify a selection area to fit the text in, but just the horizontal length. the height of the rectangle doesn't matter. Then I can write the text. Unlike the single text, this time a temporary tab for editing text appears on the ribbon. Here I have options for editing a paragraph and much more. If I want to change the height, I need to select the text and change it here. As you notice, it's very simple to write text in Autocad. Part 4. In this part, I'm going to teach how to scale objects, how to attach an image to the drawing and apply a scale in order to have the real dimensions, how to import a PDF file, and this is especially useful when the file was previously created within Autocad, how to stretch objects, and how to fill enclosed areas with the command hatch. Of course, as always, I like to share some tips with you along with the explanations. Let's start. Scale objects. Let's learn how we can scale objects. This command is not hard, but you should understand it well if you want to use it properly. To turn on the command scale, click on the icon. It's this one. Select the objects I want to scale. In this case, I want to scale the figure on the right. Choose this base point. Now, there are several modes to scale objects. The one by default is to insert a scale factor. I am going to type 2, and the lengths of all these lines changed to double size. Okay, I'm going to repeat the process, but this time I want to shrink the objects to half size. I type SC to activate the command again. Select the objects, but now I don't select the dimension line. For the scale factor, I insert 0.5, and the lines were converted to half of the length that they used to have previously. Look that this dimension line was updated, even it was unselected. Scale with a reference. Now I'm going to show to you how to insert a scale with a reference. I turn on again the command scale and select the objects. Select the base point. Looking to the command bar, it says specify scale factor or these options, copy and reference. I'm going to use the shortcut R to use a reference. And what I need to do here is draw a reference line and type a new length for it. So it's very simple. I click for the first point and then I click for the second point. Finally, I type the new length, which is 55, and press enter to confirm it. Use scale to import a PDF or attach an image. In AutoCAD, it's possible to insert an image to use as a background of a project. For example, images from Google Earth can be used to draw site plans. To attach an image file, I go to the Insert tab at the ribbon, click on Attach, and select an image from my computer. I choose this one. In this window, I can set few options. Here, it's important that I tick on Specify on screen the insertion point. Otherwise, the image is inserted on the coordinates which are specified here. Okay, except if it's exactly what you want. I click on OK, and now I click for placing the image. And for the scale factor, I leave it for now, press enter. So what happens here? Most of the time that we insert an image, it's not scaled properly. For example, I have a reference between these 2 points, which is approximately 206.17 meters. If I use the distance command, I type di, press enter, I can notice that the distance here is a bit longer than what it should. No problem. I can use scale with reference. I turn on the command scale, select the image by clicking on the border. If I click inside the image, it doesn't work. Change the mode to reference, and then I draw the line between those 2 points. I will try to make it as accurate as possible. Now it should be correct. And I want to share a tip with you. Always try to use a long reference line. Because if instead my reference was a short distance, after scaling the image tends to be less accurate. To import a PDF file, I can click on the icon also located on the Insert tab here. I'm going to choose the file of the exercises. Then the window that opens has a bit more complex options than for attaching images. Actually, this is a very useful function because if I insert a PDF that was previously created in Autocad, I can recover all the layers and the objects. As this PDF has 2 pages, first I need to click on the one that I want to import. On PDF data to import, I tick on vector geometry to import the lines, polylines, circles, arcs, and so on. If I tick on true type text, text created with a font that has this symbol will be automatically recognized as text. In AutoCAD, most fonts available are true type, so usually this is not a problem here. The option below, I tick on it if I have raster images attached. In this case, there aren't, so I keep it unselected. Then, on the right panel, I tick on the first option, Use PDF Layers. On the panel below, you can find more options to add. But for now, let's click on OK. And I am going to insert a file on the project. Nice. Now, if I go to the layer properties, I can see that new layers were created from the PDF, and due to the fact that I made this drawing in AutoCAD, the layers are the same from the original DWG file. I'm going to check out how the objects look like, and you can see here polylines among other objects. Also, look how the text was recognized. If the text was not on a TrueType font, it would be splitted in very small lines and arcs, which wouldn't be so interesting. However, not everything is perfect. The dimension lines are not recognized, neither block references, which means I have to create them again. But in general, insert PDF can be very useful. Just be aware, it's only available in the versions after AutoCAD 2017. Stretch objects. Sometimes in AutoCAD we need to stretch figures. Let's learn how it works. First, it's important to have in mind that this operation doesn't work for blocks. As you can see, here I have only lines and polylines. Let's do it. I am going to click on the command stretch. It's this icon here. Then I have to select the part to actually stretch. So I open the selection from the right just until here. Then I specify this base point. As you can see, I'm extending and moving objects to this side. And as the dimension line was in the selection, it is also readjusting. Now, I can click to place the objects exactly how it's on the screen, however it's without any kind of precision, or type a distance to extend. If I type 800, Actually, I add that value to the original length of 600, and the total is 1400. The way that the objects stretch depends only on the selection. Even I select a different base point, the result is the same. Let's repeat this again, and this time I want to change the selection to cover also this line. I press Enter, and you can see the object stretching differently. Now I want to try to stretch vertically. I select the objects, press Enter, and oh, it's not as I was expecting. But I select all the objects. Why does this happen? When I was doing the selection, I kept these sides outside of the selection area. And even everything was selected because the external rectangle is a polyline, a single object. The really important thing here is what actually I am covering with the area. Hatch. Filling enclosed areas. In this section, I will be talking about a drawing tool which is used to fill enclosed areas. It's the command hatch. But first, I am going to create a new layer in this file. Let's check out if you remember how to do it. I go to the Properties Manager, click with the right button, and New Layer. I name it as simply Hatch. Then I'm going to choose a color for it. For example, this kind of pink. OK, now I'm going to turn on the command hatch. It's located here at the drawing panel. Wait a few seconds if you want to read the description of this tool. Sometimes it can be interesting. Then, to apply a hatch, click on it, and I have to click inside an enclosed area. It can be any of these rectangles. I click to fill this one. Ah, it's in a white color. I forgot to change the layer. Yes, when you create a new layer, you still need to set it as the current layer before you draw the objects in. Otherwise, it will not work. Go to the Layer tab and click on Hatch. Now I see this message appeared. The current layer will be turned off. What do you want to do? For any reason, this bulb is switched off, and if I draw objects on that layer, they will not be visible. Click to turn it on. I'm going to repeat the process. Click on the command Hatch and fill that area. Now it's on the correct layer. Press Enter to confirm. Then, by dragging the mouse over, you can see that it's a hatch object. Now I will show you another way to use hatch. I click again here, and then, instead of pressing Enter, I fill a different area right away. What happened is that both areas are now a single object. Hatch Editor. Above, a new tab appeared at the ribbon specialized for editing hatches. I'm going to show you briefly the functions here. I'm going to click on this button at this panel, and you can see a lot of patterns to use here. The first one, Solid, is the simplest one. It fills the area with just one color. I choose, for example, this. Now let's have a look at the options at this side. On these controls, I changed the scale. Look how is the effect. On the Angle tab above, I can rotate the pattern. Finally, on Hatch Transparency, I add a transparent effect to the objects. I want to mention one thing. When I first tried to change the scale by clicking on the controls, I realized that these values didn't change a lot. Even if I type a number with decimals, it shows just 0. When this happens, it means that I should go to the unit properties, type UN and press enter. And in this tab, I need to set decimals. For example, 2 decimal cases. Then it should work fine. Part 5. How to use array. With the command array, we can copy objects arranged in a pattern. There are 3 different modes: rectangular array, polar array, and path array. I start with rectangular array, and for that I just need to click on the button, that's the mode set by default. Then I'm going to select these objects and press enter. So an array was generated and a special tab on the ribbon has appeared. Now I can edit this pattern as I wish. Here I can set the number of columns and rows. If I decrease the number of columns, for example from 4 to 3, as you can see on the screen, the last column is suppressed. The array creation, I find it very intuitive. And I think it's easy to understand the options here, while looking to these little drawings there. The distance between is the distance from the origin to the beginning of the next element. The distance total is from the origin to where the last element starts. Simple. I'm going to change the distance between rows to 200. And look how the pattern moves. Of course, the total distance was updated in order to match to the new distance between lines. To exit the array mode, I press escape. Now, if I want to confirm the distances, I can use the measure tool or type DI and press enter. Notice that the vertical length between 2 elements matches, as well as the horizontal length. Grips in an array object. Whenever I select an array, you can see these dynamic grips, the blue buttons here, which I can use them to modify this array. For example, if I click on this one, on the second row, I can change the vertical distance between 2 objects. For that, I simply type the new length. To change the horizontal length, on the other hand, click on this one. If I click on the grip at the last row, I can add more, for example, 7. If I click on this side, it's the numbering of columns that I can change. The grip on the opposite corner changes both rows or columns by dragging the mouse. Basically, these operations can also be performed on the Array tab, but sometimes it's just more practical with these buttons. Another useful thing in Array is changing the base point. I click on this icon, set the new point, for example, or on the corner, and the grips moved with the base point, but they perform exactly the same actions. Let's make a polar array. I'm going to draw a small circle with its center located at the boundary of this big one, on this side. Now I can click on the command polar array. It's this one there. Basically, what I want is to have this object displayed around. I click on it, then the center point of array is going to be the center of the biggest circle. And that's the result. The program sets 6 circles around by default, but like for the rectangular array, I can edit this on the tab at the ribbon. So, the Array tab for Polar Array is a bit different, especially the panel items. On the first parameter, I set the number of items. In this case, I specify 18, and they cover all the circumference, because I have 360 degrees for the fill parameter. In between, I specify the angle between two items, and in this case, it's 20 degrees. If I try to change the angle to 30, you can notice that it doesn't work, because it's not possible to fit 18 items with that spacement. Let's try 15 degrees. So what happened here? In order to keep 18 items, the angle on fill was updated. Now it's only 255. Grips on Polar Array and tips. The small square on the original item allows me to change the radius of the array. I'm going to set, for example, 50, and this is how it looks like. The grip on the center can be used to change the position of the array. On the other hand, if I click on this little arrow, I change the angle between two items. Let's suppose I want 6 items. The angle to have them distributed equally is 60 degrees. However, it's possible to increase a bit that angle, but the last and first item will stay closer than the others. Path Array. The third array mode available in Autocad is Path Array. We can copy objects along a line or a curve. Let's see how it is. First, I'm going to draw a spline, which is a smooth curve. I click on the command located here, Spline Fit, and I can draw a curve by specifying some points. On Spline Fit, the curve crosses exactly the points that I insert. When I finish, I press Enter. Here, by pressing Escape instead, it cancels the command. It will not work. Next, I draw a rectangle on the first endpoint of the spline. Now let's use the Path Array. I click on the icon. Select the object to copy. Press Enter, and then I select my path. So I have made it. However, probably I want to edit the spacement, position, or rotation. At the command bar, you can easily check out that there are several options to edit. Let's analyze some of them. Base point. The base point will be exactly at the start of the path. I click on the option, then I change, for example, the base point to the opposite corner. And that is the result. The object's moved, but without rotating. Tangent direction. This one is useful if I want, for example, to have one of the rectangle edges tangent with the curve. I'm going to click on the button Tangent Direction, then just specify 2 points, and the objects will rotate. But now suppose that I want the path to cross the center of the objects. I'm going to use the option Base Point and click on the center of the rectangles. But it's not snapping to the center point. If this happens to you, it means that you should turn on the mode Geometrical Center in Object Snap. It's this one. Now it's going to appear. I just need to hover the boundary first and click on the center. Array tab on the ribbon. The tab on the ribbon is now specific for path arrays, especially the first panel. I can change here easily the spacing between, total spacing, and number of items. I think the best way to absorb these things is to simply practice. You can play around with all these options and after a while it will be easier for you. Explode objects. Once I create an array, all the group is considered a single object. Now imagine that I want to get rid of the array. It doesn't work with just select it and press delete. It erases the whole thing as you see. What I need is the command explode. It basically returns a compound object to its original components. It's very easy to use this. I click on the command explode, select the array and press enter. As you see, all these are now separate polylines. Then I can manipulate the objects as my preference. Consequently, I can explode the polyline in separate lines. Another way to use explode is on blocks, hatches, and other kind of objects. But some of them it doesn't work, like text. Utilities panel. Let's talk about the Utilities panel, and I'm going to start with the Measure tool. There are several ways of measuring, as you can see here. I start showing you the first one, Quick Measure, which is the one set by default when you click on this button for the first time. When I move the mouse over the objects, some dimensions appear on the screen, and these yellow lines measure vertical and horizontal distances between the closer objects. On the other hand, if I try to check the dimensions in a circle, at the first time it looks a bit confusing, all these values here. But they just show the radius of the circle they indicate. For example, 100 is the radius of the biggest circle, as well as 15 is the radius of the small circle. The yellow lines don't measure anything here, just don't care about them. Honestly, this quick measure it's not my favorite, because even it's true that we can have a lot of information at the same time, it can be a bit confusing. But of course, that is just a personal taste. The icon distance, I use it a lot as I find it very intuitive. It simply measures the linear distance between 2 points. Another one which is very easy to use is radius. I only need to click on a circle to check it out. Measure an angle. This one is simple. I can select two lines to measure the angle between them. Or I can check out the angle of an arc by clicking on it. Now let's go to where I was before. I want to focus on something. When I select the objects to measure the angle, this menu appears where I can choose from different types of measures. I'm going to click on, for example, area, and with this I can measure the area of the triangle. It's very simple. I just need to click on all the vertices and press enter at the end. Then you can see in this box the area and the perimeter. But how could I measure the area of a circle since it doesn't have corners? I click on the icon. Then at the command bar I can switch to object. I type O and press enter. Finally, I just select the circle. Quick Select. On the Utilities panel, you can find other tools at the small icons at the right. The first one above is Quick Select. If I click there, I open this window where I can select objects by using filters. For example, I can specify a type of object or select by color. Now I will select all the objects with color cyan. Click on OK, and here it is. This is the only one in this color. Other options can be select all the objects of a specific layer, or you can select by line type, among other options. If I click on this icon, I select all the objects in the workspace, except the ones that are frozen or unlocked layers. The button below is the quick calculator. Actually, it's a kind of scientific calculator, and there we can do from basic calculations to a bit more complex ones. Part 6. The final part. Dimension lines. Now I am going to teach you how to draw dimension lines. This is a classic feature for annotation in your drawings. In this figure, you can see the dimension lines indicating its distances. Now, to draw dimension lines, there is a panel on the Home tab here. Or if we go to the Annotation tab, we can have all the tools. So there are several types of dimension lines, whose you can find them by clicking on this arrow. For now, let's start with the most common one, linear dimension. To insert a dimension line, I just click on 2 points. Then I click again to put the dimension line on the place that I want. So it's very simple. However, this feature is quite complex, and we usually have to set up some settings. Sometimes the dimension lines are not proportional with the sizes of the objects that they measure. So I'm going to open the Dimension Style Manager by clicking on this little arrow. Here, I need to choose the dimension style that I want to edit. I select Standard, which is the current one, and I click on Modify. Now there are loads of options here. But for a beginner, the most important is the size of the text and arrows, as well as the units. Go to Symbols and Arrows tab. Look for arrow size and put a value that seems convenient. Then the size of the text can be changed in the Text tab. As you see, both sizes have a height of 2. To confirm this, I can always measure the distance here. You can see it's 2. On Primary Units tab, I can edit the unit format. The number of decimals, let's change it to 2. And I can add a prefix or a suffix. For example, suppose that the units here are in meters. I can type the symbol M on suffix to appear after the values. Like this. Other types of dimension lines. As I showed in the beginning, there are more types of dimension lines to use in AutoCAD, depending on what we want to measure. For example, let's measure using the linear dimension, the distance between this point and this one. As you see, it's measuring either the horizontal distance or the vertical one if I move the pointer this way. But this is all fine because I can insert an align dimension. With this option, I can measure objects that are not located in the Cartesian axis. So it's much better, as you see. Angular dimension. Now I am going to click on the angular dimension. This one is still simple to use. I can measure an angle by clicking in 2 lines that intersect each other. The angle itself I can place in any of the 4 sides of the intersection plane. Radius. To measure the radius of a circle, first I'm going to draw one here. Then I choose the option to measure the radius and just click on the circle. I click again to place the dimension line. In this tutorial I want to show you also the arc length. I can measure the distance of an arc. And yes, this only works on arcs. If I try to measure the perimeter of a circle, nothing happens, as you see. Apart from those tiles, there is the automated dimension, which is the icon here. It detects automatically what is the most suitable type of dimension in each situation. For example, if I move this line, this square appears, and I can click on it, and I will place the dimension of the length of this line. I can do the same for the other lines, as you see. For measuring an angle, I have to choose the option Angular. And then I can place it like I did previously. In a circle, the automated dimension places the diameter by default. However, I can change to place the radius instead. Now let's see some tips and peculiarities. DimLayer. On this tab at the panel dimensions, I set the layer where I want the dimension lines in. I choose the layer dimensions as I created it specially for placing the dimension lines. However, if I switch to the Home tab, the current layer is lines. And if I draw a dimension line, you can see that it goes automatically to the dimension layer. Snaps on arrows. In some versions of Autocad, like the one that I'm using, the system snaps to the endpoints, midpoints, geometrical centers on the arrow shape. And this is a bit annoying, because usually I only want to snap to the end of the dimension line, this point. And honestly, I haven't figured out yet if there is a way to get rid of those snaps. If anyone knows, is welcome to post a comment on this video. It would help a lot of people. However, I'm going to share with you a good way to deal with this. On Symbols and Arrows tab at the Dimension Style Manager, click on the first arrowhead. And as you can see, on this list, there are plenty of them to use. But for now, I choose None. Automatically, the second arrowhead is updated to match the first one. The result is this. It's easier to snap to the endpoint. Additionally, the distances extend beyond dimension lines and offset from origin are these ones that I show on the drawing. Put 0 for both, and it's even better. I can only snap to the intersection of the line below and to the dimension line end. Basically, you can make all your projects with these settings and just edit the style according to your preferences when you finish. The dimensions will be all updated. Choose the style of dimension line before drawing. Whenever we draw a dimension line, we should make sure that the desired dimension style is active. For example, I'm going to switch to annotative and as you see, the settings there are different. Another thing, what I have been teaching during this tutorial are the standard dimension lines. All the sizes that we set on the Dimension Style Manager are according to the workspace. The annotative dimensions are the styles which are represented with this icon here. The sizes that we set are according to the real size of the dimension lines on the paper that we print. However, I will skip the annotative dimensions on this tutorial, but if you are curious, click on the card that is appearing now. So we have reached the end of this tutorial. Now you have to practice the knowledge that you got here, but of course, there is a lot more to learn in AutoCAD. Have a look in the channel CAD in Black and check out the playlists there. Maybe you find something that suits you. Thank you very much for watching and see you next time.